Okay, so this is the density experiment, and you see we've got our materials here. This is just plain old water. This is oil. This happens to be canola oil or old fish frying oil. And this is rubbing alcohol, and I've dyed it red because it's more fun that way. And this is the container that we're going to put them all into very carefully so that we can see the layers and the separation of these liquids. And this happens to be a fancy flute glass or something, so we'll use that. So here we go. One of the things that's very important when you're doing this experiment, if you want to get good results and have it look pretty at the end, is that you pour down the side of the glass. You decant is the technical term for it. You just don't want to pour straight down the middle so that your liquid all drops down in the middle all messed up and tumbly. It's just kind of not have it go down the side of the glass nice and easy like that. And you'll get much better results. So it's not as important with the water, but now when we get to the oil, it is going to be more important. So what should happen here is that the oil should just sit right on top of the water and not mix up with it, because it's lighter than the water. So let's see what happens here if I can be steady with this. Alright, there we go. Spill a little bit, but that's why we've got a towel under everything. And already there we've got some great separations. I don't know, I think that's really cool. So here, let's try the rubbing alcohol at the very last here. Okay, and then there's just a tiny bit of rubbing alcohol on there because we don't like to waste rubbing alcohol. So, great separation, and as it said in the lab, there's a couple of reasons that these liquids stay separate, that they don't mix together. First, obviously what we're talking about, what we're interested in, is the differences in density. So the weight per unit volume of these three substances is different. Water is heaviest, and then oil, and then rubbing alcohol is the lightest of them all. And then if you really wanted to get split hairs and talk about it, you could say that the air above all of it is even lighter, and that's why air doesn't just suddenly sink down into these liquids. Another one of the reasons that we're not as concerned about, but I've talked about in the lab, is there's the different polarity of these substances kind of has to do with their electrical orientation of the actual molecules, but we're not going to worry about that a whole lot right now. So, great separation. Let's see if we can take this. We should be able to turn it over. How do we do? How do we do? Can you see it? All right. Check it out. Awesome. So, again, the different densities and the different polarities of these liquids are keeping them separate even when we turn them over. So now, since this is pretty well the end, I'm going to shake them up and let the glass sit. And what we should expect to happen is that they will re-separate out. Or, well, the water and the alcohol will probably stay together. But we'll probably at least have two layers. We'll have the oil in one layer and then the water-alcohol mix in the other layer. Because of the different densities shouldn't allow them to stay the same along with the polarity. So here we go. Got a nice orange slush there. So we're going to leave this here for about 30 minutes, come back, and see what we find. And hopefully there will be two layers if Mr. Elfrink's right. And if Mr. Elfrink's wrong, well, we'll all continue about our days as if nothing happened. So, okay, so it's been about 30 minutes, and as I predicted, we've got two layers here. The oil did separate out from the alcohol in the water, and voila, fantastic. So that's the end of the experiment proper. Different densities, separation, great. And now just for fun, we're going to throw an Alka-Seltzer in, which will go down through the oil into the water and cause the water to bubble up, and it'll look pretty cool, kind of like a lava lamp. Is the density of the water is going to keep it together even through the oil, and the surface tension of it, and also the polarity. But just for fun, Let's see what happens.
Aha! Well, isn't that nifty? We just created our own lava lamp there.